guys, today we are going to be talking about proportional situations again. We're back to proportional and non-proportional situations. And today we're doing 8.5a, where we're going to represent linear proportional situations with tables, graphs, and equations. And remember that when it's in a proportional situation, the equation is in the form of y equals kx. So let's review what these mean. This is our y value. K is our constant, okay, which is also our slope. So don't forget in K, okay. M is our slope in y equals mx plus b, but that's the same thing as our constant. That's also our slope, or our constant rate of change. And then x is our y value. I'm sorry, x is our x value. Why on earth would I say it's the y value? Okay. So we're representing these situations with tables, graphs, and equations. So you're going to be given a situation on each one of these questions. Sometimes you're going to have to come up with the equation, which is what we're doing on number 1 and number 2. Sometimes you may have to create a table, and sometimes you may have to identify a graph. So remember that tables, graphs, and equations are just all ways of showing the exact same information. We can show it all 3 ways when we're given a problem, or they're just going to ask us to show it one way. But remember that it's all the same thing. It's just some people like looking at tables, some people like looking at graphs, some people like the equations. So we need to be able to show that data in whatever way the STAR test people want us to be able to show it. Okay, so let's look at number 1. We're told that Anne is traveling by bus to see a friend who moved away from her neighborhood. So in that first sentence, we're given part of a story. So once we're given part of a story, it's a good idea to kind of put yourself into it or start picturing it. It's almost like a movie. You can even close your eyes and picture Anne traveling by bus to see her friend. And there's probably smells really bad on the bus, and you know, there's probably crying babies and all kinds of stuff. So just imagine yourself on that bus. She has been on the bus for 2 hours. It's a long time to be on a bus. And she's traveled 120 miles. And then it just says which equation can be used to show the distance, d, she will travel in hours, t, so t for time, assuming that the bus travels at a constant speed. So it travels at a constant speed. And we know that this is a proportional situation because at 0 hours, how far has she traveled? 0 miles. Okay, so it starts at 0, 0. That's just common sense. We know that if you get on a bus and it's been 0 hours, you haven't gone anywhere. So this reminds me of our distance formula. Distance equals rate times time. Remember that we could draw our little triangle here. This is drt. So if we had been given the distance and we were looking for the time, then we would do t equals distance divided by rate. So use this triangle to help you if they don't ever give you a formula. So we are looking for distance because it says which equation can be used to show the distance that she will travel in this many hours. So how far is she going to travel in 1 hour? Well, I know that if she's going to travel 2 hours and go 120 miles, then in 1 hour, she's going to go 60 miles. So 60 miles in 1 hour. That means I'm going to go ahead and plug in d equals 60 times the time, 60 miles times the number of hours, and that's this answer choice right over here. So we took this proportional situation, which in this case deals with the distance formula, so we had to know that, and we were able to form an equation from it. And remember, this is our constant. 60 miles per hour is the constant speed. That's our K. Let's look now at number 2. Lynn charges $12 to wash a car. $12 for one car. Which number sentence, that's just another word for equation, can be used to find M, the money he would make if he washed C cars? So I know that $12 per car okay, that's how we would say it in English, but in math, we would write it like this, 12C, because this is 12 times the number of cars. So on all of these questions where it's asking you to come up with an equation, this is how I'd like for you to show your work. Go ahead and turn the English into a math phrase, 12C, is the same as $12 per car, or when you find your answer, you can just write that out. So this is one way to do it. This would be our answer, the amount of money equals $12 per car. Okay, so you could write that to just show me, okay, $12 per car, same thing. But write something out to the side so that when I'm giving you your stamp, you're able to prove to me that you didn't just choose an answer. For example, this one would not work. This would be $12 plus the number of cars. So if I washed one car, I'd have $13. Two cars, I'd have $14. That doesn't make any sense because it's $12 for each car. I don't know where this came from. This, I can't even figure out what this one would have been. I guess $12 plus $12 plus the number of cars, so $24 plus the number of cars. Again, that won't work because F wouldn't work. Let's look at number 3. I'm not going to do this whole question with you, but I do want to kind of start it off. So it says, at their first track practice, Jan ran 1/4 of a mile, June ran 2/3 of a mile, and Cody ran 1/2 of a mile. They want to be able to run 3 times as far by the end of the month. Okay, so I'm going to start by saying 3 times as far. So that means I'm going to multiply all of these fractions by 3. Which table represents the distances that Jan, June, and Cody must be able to run by the end of their month in order to meet their goal? So I have Jan at 1/4 mile, June at 2/3 of a mile, and Cody at 1/2 a mile. And I need to multiply all of these times 3. So one option that you have is to turn everything into a decimal. So I could turn 1/4 into 0.25. I should have this memorized. 2/3 is a little trickier. That's 0.66666666 for on and on forever. So I'm going to say 0.67. Remember, that's a little bit of an estimate because I had to round. And 1/2 is 0.5 or 0.50. So think of this like money. 1/4 of a dollar is 25 cents. 1/2 of a dollar is 50 cents. So that's one choice that I have. Another choice is to go ahead and just multiply out these fractions. And that's what I'm going to show you here with Jan. I'm going to scoot this over just a little bit. And I'm going to do my work for Jan over here. So Jan originally ran 1/4 of a mile, and I want to multiply this times 3. She wants to be able to run 3 times as far. So times 3. Well, the first thing we need to do is change mixed numbers to improper fractions and put whole numbers over 1. So 1/4 stays like this, and this becomes 3 over 1. Now, I'm in luck because since I'm multiplying, I don't have to have a common denominator. I don't really even want one. I just multiply straight across. So 1 times 3 is 3. 4 times 1 is 4. 3/4 cannot be simplified any further, so that is my answer for Jan. Now, I know that there's only one answer choice over here that would work for Jan, but I still need you to go ahead and prove June and Cody. So if we look over here, I need you to show me, let's go ahead and just give ourselves some space here. Let's do June. And Cody. And I'd like for you to set these up. So again, you could do two things. You could either do 0.67 times 3, and then remember that you would need to turn that back into a fraction since all of your answer choices are fractions. Or you can start with 2/3 and multiply that by 3 like we just did with Jan. Same thing with Cody. 1/2 times 3. So follow those steps. I need you to show me, before I'm going to give you a stamp on number 3, you need to show me that you have figured out Cody and June's final distance as well. So please go ahead and finish number 3. As soon as you finish number 3 and you're able to show me your work to prove it, then bring me your paper and I will give you your stamp for number 3. So please pause the video now. Now that you have your stamp for number 3, I'm going to turn you loose on numbers 4, 5, and 14. So those are the ones that I want you to work on right now, just 4, 5, and 14. All three of these are similar. They're all asking you to come up with an equation to fit the situation in the word problem. Now I want you to be very careful because a lot of times you have to kind of rely less on thinking like math and more on thinking like real life common sense. How would this really work? So think to yourself like that if you can. This is a great opportunity to kind of apply math to real life or make-believe life in this case. Remember that just like we did on number 2, okay, just like we did on number 2, I need you to prove to me why the answer you chose works. So put it into words somehow. Here it was money equals $12 per car, so 12C. So however you want to do that, whatever works for you, as long as you can prove that to me for numbers 4, 5, and 14. When you're finished with 4, 5, and 14, please bring your paper to me so that I can give you your stamps. So you can pause the video now, please. Now that you have 3 stamps on the back, number 4, number 5, and number 14, please turn your attention to number 7. You guys are really, really good at figuring out which tables and which graphs and which equations show a proportional relationship, and that's all you're doing in this problem. So please go ahead and read number 7. You're going to answer the question, which table shows a proportional relationship? I need you to prove to me or circle or highlight or something what shows you that your answer is actually the one that's a proportional relationship. A good way to do that is to also prove why the other 3 choices are not proportional relationships. So before you bring me your paper, make sure that you have your proof written down. Then you can bring it to me for a stamp. And please go ahead and pause the video now. Now I'd like for you to look at number 6. You're turning this table into an equation, but what I want you to look carefully at is that our x values, these hours, do not start at 0 and go all the way up one at a time. So they've just picked and chosen which hours they want to show you. So make sure you're keeping that in mind. As you're determining your constant, your k, for k, your y equals kx, as you're doing that, make sure that you're doing delta y, or change in y, over the change in x. Or, since this is a proportional situation, and we know it's a proportional situation, you could just take your x value and divide it by your y value. But we don't always know that, so it's a good idea to go ahead and use that change in y divided by change in x. And you can look back at your slope notes if you have a question on this. Please prove your answer by showing your work. When you're finished with number 6, you can bring it to me for a stamp, and then you'll be able to push play on the video to continue. So please pause the video now. Take a look with me at number 8. It says the following table shows a proportional relationship between x and y. Some of the values for x and y are missing. find the values for m and n that would complete the table. And I'd actually like for you to find p as well. So m, n, and p. So what we're going to do here is go ahead and find our relationship. So I know that I can take y over x and set up a proportion. So let's just go ahead and prove really quickly why this is proportional. I can take that point 410, so 10 over 4, sorry, that's a little bit, there we go, that's better, I think. You know what, I'm at home and my blinds are not closed. There we go. I think that's a little bit better. A little bit anyway. Okay, so 10 over 4. And we're going to prove that that's proportional by using the next point, 15 over 6. So we use our cross products. 4 times 15 is 60. 6 times 10 is 60. So those are proportional. And if we tested every other point in the table, they would all be proportional. Now we don't need to test them because we're told already that it's proportional, but this is just a good way to prove it to ourselves. So right now I want to go ahead and find m. So let's use the easiest numbers, 4 and 10. So I'm going to use 10 over 4 equals m over 10. So y over x equals y over x. And I'm going to cross multiply, so this is 4m equals 10 times 10 is 100. We know that we need to divide both sides by 4. So m, if you put that in your calculator or if you just have it memorized, m is 25. And you've proven your answer by showing your work. Now let's do the same thing for n. Oops, there's n. I'm going to keep using my 10 over 4 because those are my smallest numbers. So 10 over 4, but I could use anything in this table, any point I want because they are all proportional to each other, equals 30 over n. So in this case, n is on the bottom because it's x. I'm doing y over x. So this is 10n equals 120. Let's divide both sides by 10. I can cross out the zeros there, so I get n equals 12 divided by 1, or just 12. And let's do one more. Let's go ahead and test point P, even though the question didn't tell us we had to. Okay, we have 10 over 4 equals 35 over P. 10P equals 4 times 35 in your calculator. It's 140. Divide both sides by 10. And I know we're kind of running out of space here. I'm going to get P equals, cross out those zeros, 14. Now before I go on to my next problem, I need to look and see, do these fit in the table? So m needs to be between 20 and 30, and it is. In fact, I see that my y's go up by 5 each time the x's go up by 2. Okay, n is 12, and yep, they keep going up by 2. It's in between 10 and my next number, which is 14. So these all go in order. If I had gotten 120 for n, I would have known, man, that's way off, because that totally does not fit the pattern. So next, I'd like for you to do number 9 on your own. Make sure that you're showing your work. And it says the following table shows a proportional relationship between x and y, and you're having to find all 4 of those missing values. So you're looking for M, N, Q, and P. So please show your work. If you need to do your work on your next page in your journal, that's fine. Just label it so that you know what that is, and bring it with you when you come up to get a stamp for number 9. So your job right now is to complete number 9, all 4 parts, bring it to me for a stamp, and then we're going to move on after that. So please pause the video now. Now that you have number 9 finished, I'd like for you to go on to number 10. Please prove your answer either by showing how 2 answers are wrong or by showing how the answer you choose is right. Either one of those is fine. When you're finished with number 10, I'd like you to bring me your paper so that I can give you a stamp, and then we will start number 21 together. Please pause the video now. Number 21 says, a can of juice contains 175 calories per 2.5 servings. Which of the following is not, okay, very important, not an equivalent number of calories per serving? So basically, which one of these is not proportional to the juice that we're talking about in the problem? So I can tell that I'm comparing 2 things. The 2 things I'm comparing are calories and servings. And I know that I need to set up a proportion simply because I need to find which one of these does not have the same relationship. So I need to find 3 that do have the same relationship. So if you'd like to open up your notes to how to write and solve proportions, that was a week or 2 ago, or you can just follow along with me. Step 1 is always to name your ratio. That means the 2 units that we're comparing. So I'm going to say calories over servings. Oops, you can't see that. There we go. Then I'm going to fill in what I know. And so we're going to set up a proportion, which means I'm going to start with line equals line. And what I know is 175 calories. So that's going to go on top. Goes with 2.5 servings, and I said that servings will go on the bottom. Now I need to test all 4 of these answer choices. I'm going to do D with you because it's kind of hard to read D. So that's 630 calories. Calories goes on top. And 9 servings. So the reason we name our ratio is to make sure that we're continuing to set it up the same way throughout the problem. If I had put 9 on top and 630 on bottom, it would have completely wrecked my whole proportion. Now we need to see if these are actually proportional. So let's put 2.5 times 630 in our calculator. I'm going to do that really quick here. .5 times 630, that's 1,575, and then 9 times 175 is also 1,575. So, are these proportional? Yes, they are proportional. The question, though, does not say which one of the following answer choices is equivalent. It says which one is not equivalent. So this one is equivalent, or it is proportional. So bye-bye answer choice D. So I need you to finish number 21 on your own. I need you to actually test the 3 remaining answer choices, A, B, and C. Even if you find one that's not proportional, go ahead and prove that the other 2 are proportional. So you may need to do this on a page in your journal. If you do, that's perfectly fine. Label it so that you know what it is that you were doing there, and then bring me your paper and your work so that I can give you a stamp for finishing today's assignment.